Securing the American dream for the next generation of STEM and workforce talent. My name is Matt Kirchner. I am the host of the Tech Ed Podcast. If you tuned in a few short weeks ago when we had Dayton Horvath, the Director of Emerging Technologies for the Association for Manufacturing Technology, on with us, you will recall that he only mentioned two additive manufacturing companies when he talked about all the great things happening across manufacturing technology. One of those two companies is B9 Creations. Its CEO is Shon Anderson. Shon is somebody who I've gotten to know quite well over the course of this year. He is my guest on this episode. We are going to have a great conversation around additive manufacturing, how it relates to manufacturing itself, what we need to be doing in education in terms of additive. And it is my great pleasure to welcome to the studio of the Tech Ed Podcast, Mr. Shon Anderson, CEO of B9 Creations.
Thank you so much, Matt. It's great to be here.
And you and I have spent a fair amount of time together over the course of the last year, getting to know each other. I've gotten to know your company. Actually, we were introduced by a mutual friend of ours, Brooks Jacobson, at Lake Area Technical College in the state of South Dakota, the state where you're in. You're on the other end of the state, of course, in Rapid City. But B9 Creations doing just some amazing things in the world of additive manufacturing and 3D printing. We're going to get into that in depth. It's awesome to have you on with us to talk about this topic. Let's talk a little bit from the get-go about 3D printing in general. And when we hear from people thinking about additive, thinking about 3D printing, maybe 10, 15 years ago, people had no idea what it is. Now they're starting to get an idea. But when people think of 3D or additive, what do they think of?
You know, it spans such a wide spectrum, Matt, all the way from, you read articles about 3D printing houses to people hear about things like 3D printed wrenches on the International Space Station to things that are probably more of society has interacted with, like, hey, I went to the dentist and I got a same-day crown. For B9 Creations, where we focus is what we call ultra-precision end of that. So, we're not trying to 3D print football helmet pads or tennis shoe insoles. It's things that go in medical devices and jet engines and other things like that. But additive manufacturing can be used in a whole lot of ways. That's what gets me excited about, this whole future of STEM education, because to make use of that tool, we got to have people that understand it and know how to wield the tool.
So it doesn't matter if I'm in the International Space Station, if I'm in my dentist's office, if I'm in any really sector of the entire economy, additive manufacturing and 3D printing is going to be real. It's going to be used. And it's especially true, I think, in a lot of ways in the world of manufacturing. As you know, Shon, I spent almost my whole career in manufacturing before coming over to education about 10 years ago. So let's talk about manufacturing specifically. Is additive really able to solve problems and challenges in manufacturing? And is it really capable of transforming an entire organization or business?
Absolutely. The key to this is like any other good engineering project, it's picking the right project. So if you have a very simple plastic part or metal part that you make today, and you can injection mold that, and you're not dealing with tooling constraints or design constraints, it's definitely going to be cheaper if you're going to make 1 million of them to injection mold them. Mm-hmm. The use case for additive has always been around, prototyping or very low volume production. When you think about injection molding, the most expensive part is always part number one, because I have to cut this piece of steel to create a tool to get even the first part. What we're seeing, Matt, is that whereas it used to be additive made sense if you needed 1, 2, 10, 20. We have clients now that are using our technology to produce thousands of parts. So that break-even point on cutting a tool, or the other business case we hear a lot, we're dealing with a large company in the life sciences space who says right now they turn down a ton of business because the customer wants less than their typical minimum order quantity. And so you have these companies saying, well, normally if they're not going to buy 10,000 parts, we don't do it, even though that could be some really profitable business. And so we're seeing additive fit those. Well, it's production, but it's not 1 million parts. And the lead time compression that comes from not cutting a tool combined with the cost savings really makes the business case work.
Well, and I was just going to mention that, all those years that I spent in manufacturing, whether it was getting a die or a tool or a mold manufactured, that can take, in some cases, weeks, if not months, maybe even longer, depending on where it's coming from and how intricate it is, which really stretches out innovation. It really stretches out lead times. The part that I hadn't thought of that you just mentioned, Shon, which is really interesting to me, as somebody who worked in contract manufacturing for a long, long time, and for our listeners, when we say contract manufacturing, we mean a manufacturing company that is making a product for another manufacturing company typically. A lot of times we deal with those minimum values, or volumes, I should say. So in other words, a customer wants to send you a part. They want it in a lot size of 10. You're set up to build it in a lot size of 1,000. You might have to charge them for 1,000 parts, even though they're only looking for 10, which really, for obvious reasons, can preclude the economics of that particular project. Now, what I hear you telling me is that if I've got a particular part where the minimum order quantity might be 1,000 and I only need 10, I can use additive, I can use 3D printing to 3D print that part. We're going to get it done faster than we might otherwise would through a typical contract manufacturing route, and more economically given those minimum order quantities that aren't as big of a concern when it comes to additive manufacturing. So I learned something that I hadn't thought about before, and that really is super interesting. That's what we're all about here at the Tech Ed Podcast, is learning things. What I'd like to learn here is this, Shon. When we think about manufacturing companies implementing additive manufacturing or 3D printing, what are some of the hurdles they run into, and what should we be doing about them?
Well, that's a great question. I would say they tend to fall into three buckets, Matt. You've got material capabilities, which, whether you're speaking metal 3D printing or polymer, which is where B9 happens to sit, but they're a metal 3D printed part or a liquid photopolymer 3D printed part is not the same thing. It's close, but it's not the same thing as a 6061 aluminum that might be cast or forged. Or on the photopolymer side, you may be used to an ABS PC blend that you're injection molding. Your liquid photopolymer are going to be ABS PC like, but they're not identical. So you got that material limitation. The second thing I would say is you have to understand how set is the design. And this is what we see so often with clients. And frankly, I've seen people that you cut a tool, and just after you complete that first article inspection, somebody has a really good idea, and then you probably slap that person around a little bit because,
right,
time for that idea would have been before you cut the tool. And with additive, you're not dealing with those constraints. You ship the first batch of parts, and the customer says, could we do this? Could we do that? Could we move this hole, or could we adjust that? So you get this flexibility. You're not stuck with this design. The other big limitation that when you're thinking about choosing projects is something where you'd say, what do I want my end of life for this product? And I know we're talking about, prototyping a beginning of life, but you fast forward to the end, and what are my limitations around how many spare parts do I need for this thing? Do I want to have to make 100,000 extra and store them in my warehouse for 10 years? Because it might turn out, and where people oftentimes go wrong is they only look at the upfront cost and they neglect, well, I have to overproduce, and then I'm going to store these parts forever because I can't take a chance that if I don't make any for 5 years, I can go back to that supplier and get this part. Well, with additive, I don't need a whole lot of them in the warehouse because I can make more pretty simply and easily. That's really thinking life cycle cost and not being so focused on the front end that we neglect those back end impacts.
So when we think about those three, and particularly, let's kind of tackle the first one first. If I'm a manufacturer and let's say I'm using some form of an injection molding process, and what I'm hearing is if I switch to additive, my material properties might not be exactly the same as what I had beforehand. Did I understand that right? And if so, how do you work around that in terms of qualifying new projects and materials?
What we've found, Matt, is that you have a lot of engineers that, let's say we're going to make a new part, and the engineer, there's a set of engineering plastics that everyone's so used to working with that they'll call it, again, ABS, PC blend, Delrin, pick one.
Mm-hmm.
And so from our side, our solutions team is going to be asking, tell us what you're looking, is it heat deflection temp? What are the key attributes here that are driving that material call out? And a lot of times the answer is, well, I don't know. The last 10 of these I've designed, I just use that and it just works.
Right.
So sometimes it's challenging because customers have gotten so familiar. And this is, I think a point we'll touch on later, but we have multiple generations of engineers now educated to design for injection molding, if we're picking on the plastic world for a minute, and they know the engineering material set, They know basic tooling things around drafts and radius and all this stuff, but there's an equivalent set of experience to that has to get built into this next generation of engineers around additive. So back to our materials point, is this piece going to be exposed to UV light? What kind of temperature range? Is it going to be potentially dropped? Or, you think about something as simple as a computer mouse. Well, I can 3D print all those parts. Now, after it's 5 years old and I knock it off the desk, it's probably going to break if it's a typical photopolymer. So all those considerations oftentimes have to be thought back through that oftentimes aren't, because our engineers are so used to saying ABS PC blend or glass filled nylon or those common engineering plastics. And so there does need to be some planning when you're thinking about trying to replace an existing engineering plastic with additive.
You're taking me back a little ways to my contract manufacturing days and making material handling solutions for, let's just say, a major motorcycle manufacturer here in the United States. And all the fixtures on that were made out of Delrin, by the way. So used to that, right? I mean, that was what every engineer wanted to spec because that was a material that they were familiar with. I also think back to my days of metal finishing and metal plating when the personal exposure limits on hexavalent chromium came along probably 15, 20 years ago, and we had to switch some of the customers to new solutions in that regard. And it was exactly, in a lot of cases, very similar properties, but they were so used to saying copper, nickel, chrome. They were so used to saying Delrin that making the switch was a little bit of a challenge just in terms of the psyche or the way they thought about the product. Let me flip the script on that, though, a little bit. And are we into an age where, because of the flexibility we have in materials with additive, where we could actually maybe inject or include some material properties in a solution that those engineers aren't thinking of or aren't aware of, but in the end would actually improve the application and the goals that they're trying to meet?
For sure. And it's everything from, sometimes it's a basic material property, but other times, Matt, it's more complex and it's like designed in flex in a part.
Sure.
It is very difficult to control with the geometries and things that I have available. Let's say in injection molding, I can't use some kind of lattice infill, for instance, to provide stiffness or a prescribed amount of give. I can't injection mold that, but I can 3D print a lattice infill and provide a different level of stiffness and give. What I always tell the engineer is, the printer doesn't care about the cross section. The printer doesn't care about the geometry. I don't need to be able to get a tool in there. It doesn't have to pop out of a mold. That doesn't mean that there are no considerations. There certainly are designed for additive considerations, but that design freedom, the challenge is what customers usually bring to us is, here's the part I make today. I just want to make this exact same thing with additive.
Right.
When you do that, you're not leveraging the design freedom. You're not leveraging a whole bunch of stuff because obviously you already own a tool or you wouldn't have been making it today. So those projects, and part of it, it's just retraining our engineers when they think every engineer probably had to take that engineering economics class.
Right.
It's taking them back to that engineering economics class and getting them to build some new variables in the equation as they're choosing projects.
Absolutely. Well, you have somebody that comes to you and says, I just want this part to look and feel and work exactly the same as it did with the other process. And you're like, well, wait a minute, what if we could provide the same level of strength and stiffness, but do that at a third the weight because we use infill as opposed to a solid part? Would you like that as just one thought? So there's all this flexibility that we have with additive manufacturing that we may not have had with other traditional manufacturing methods. Not that it's the be all and end all of manufacturing, because every method finds its best solution and vice versa. But certainly some of these advancements are creating all kinds of really successful projects and opportunities in manufacturing. Are there certain things that differentiate those successful projects, Shon, from the ones that maybe don't go as well in manufacturing when you think about 3D printing?
There are, and I'll tell you, it's a little bit counterintuitive. My experience, though, is the successful projects are more about the organization who's implementing than they are about the technology. And, that human factor cannot be understated. I'm going to paint with a broad brush, and usually when I do that, I regret it, but I'm going to do it anyway.
Go for it.
Almost any project you're going to do with additive will have some different considerations. Even if it's not on the front end, it may be post-processing or packaging, or, there's going to be a change somewhere, and your whole organization needs to understand the reason for the change. What is it we're getting out of this? And so, I always sympathize with the one engineer that got tasked to take this, again, I'll pick on the mouse, but hey, find us a better way to make this part. And so He looks at the materials and looks at the design and all the things, but he doesn't think about, well, the procurement department has to add a new vendor, and now we're not ordering them in quantities of 50, and the inventory system, everything we do is on quantities of 50. And, I'm throwing out what sound like some kind of inane things, but you would be amazed at how many of these projects that may have a good engineering or financial basis struggle for adoption and long-term success because of those human factors or organizational factors.
Actually, I wouldn't be surprised by that at all, because by somebody who worked in manufacturing for 25 years, I dealt with that kind of stuff all day long. And if you can get it all the way through manufacturing and procurement and customer service and the customer, then the accounting department, and I'm a recovering bean counter, so I can say that we'll come up with a reason not to do it. So I certainly recognize what some of those challenges are in terms of driving change in manufacturing. And so I want to just come back really quickly to what you said in terms of the organization. Does it really come down to the culture and how innovative and progressive the organization is, and how holistic their view of innovation and being progressive is? Or what do you think are the keys with regard to the organizations that make these projects work versus those that don't?
Well, again, I'll paint with a little bit of a broad brush, but based on our shared manufacturing background, I think I can say that some organizations are just better at change and innovation than others because of what they have chosen to reward and recognize and encourage in their culture. It doesn't matter if you're talking about a new HR system or a new production process. If your organization is good at change and good at innovation, your odds of success are much higher. It's amazing to me how many companies, if I went to them and said, if you were going to set up a new production line and you're going to switch from molding these parts to milling, what's your change management process? And they would come to me with a book, right, that's 3 inches thick. Yet when they go to do something with additive, they forget that they have you've already written a process for how to do this. Don't throw that out. Now, it doesn't mean it's all word for word going to be the same, but if you applied the same discipline and the same, oftentimes it's communication, right? So these downstream business partners understand what's coming before it hits. Those muscles that, as you understand, Matt, if you build those into your organization, any change goes better.
Well, in this day and age, when it comes to change, innovation, agility, I mean, those are going to be the names of the game. Shon had Barbara Humpton on the podcast not too long ago. She, of course, is the Chief Executive Officer of Siemens USA. And we talked all about change in manufacturing and just in our way of manufacturing products globally. And there's so many geopolitical things going on now, of course, post-election, with questions on tariffs and questions on international trade and so on. Nobody knows for sure where those are going to go, but I think it's safe to say we're going to see more and more manufacturing getting closer and closer to the point of use. We're going to see more flexibility. We're going to see more consumer opportunities in terms of choice and making decisions about what exactly they want. We're going to see smaller lot sizes, way more mix. It's going to be a fascinating time to be in manufacturing, but the truth of the matter is that, at least in my opinion, if you're a company that is good at change and innovation and you're agile, as you suggest, you're going to be in a position to adopt some of these technologies. If you're not only not going to be in position to adopt these technologies, you're probably not going to be in a position to grow or even exist 5 to 10 years from now. So I think some of these things we're talking about, which are nice to haves in manufacturing, are going to be absolutely critical going forward the next 5 years. It's going to be really, really fun to watch as we see some of our companies, in fact, a lot of them across the United States, finding ways to be more innovative, finding ways to be better at change management and be more agile. If you had a couple of pieces of advice for those companies, let's say I'm a VP of operations, or I'm a vice president of engineering, or I'm even a president or CEO of a small to mid-sized manufacturing company thinking about integrating additive, how can I ensure that the additive world and the 3D printing technology I'm adopting is going to serve my business goals and also integrate really well into my overall process?
Well, that's a great question, Matt, and one that I hope everybody in manufacturing listens to this podcast, because
they do, everybody.
It's a question not enough people ask, and I would correlate it to, I think most people at that VP level are probably familiar with the whole make versus buy conversation.
Sure.
Of, hey, should we make this or should we outsource that? People need to think more about what level of expertise around additive is it realistic for us to have internally, and then pick a strategy with how we're going to tackle this project that, again, if it's we're the experts at everything, we can afford to hire everybody we need to hire, just give us the equipment and turn us loose. Okay. I don't actually see that work very often, but okay. Right. I think if you think about the breakdown of size of American manufacturers, and this is part of why B9 has taken the approach we've taken, there are a handful of very large manufacturers, but it's a handful. The vast majority, and frankly, you probably know the numbers better than I do, but the vast majority of manufacturing firms are really in that mid-sized boat. And it's not realistic for them to say, I'm going to dedicate 10 people to this additive initiative, and we're just going to go fumble around at this for a year trying to make it work. And I'm going to burn $500,000 of CapEx and another $1.5 million of OpEx. But in the end, we'll be able to replace one part we used to injection mold.
Right.
That is not practical. So
you'll be out of business before you get there.
Absolutely. Or, your shareholders will have swapped CEOs long before you get that figured out. So our approach has been, rather than traditional 3D printing world, has been very much distribution oriented, very much just product oriented. Not that we don't do distribution work, but we very much focus on the consultative services it takes to get the business outcome. We work hard with our team internally. Our definition of success is not that you bought a printer. Our definition of success is not even that you got it to print the part you wanted. We try to understand the business outcome you're looking to drive and then wrap the services and solutions around the software, the hardware, the materials, et cetera. Because ultimately, if we're honest about the additive manufacturing industry, as much as has a ton of potential and it is really changing the way a lot of things are made, it's also known for more hype than results. And we're on a crusade to change that. What most customers want is to minimize distraction so they can go be good at whatever they're trying to be good at, right? And so our approach in the very simplest of terms is, how can we be the additive experts so that our customers get the luxury of it's hard enough to be good at your business. They shouldn't have to try to figure out how to be good at our business.
That's exactly right. And in every business that I'm in, we talk all the time about focusing on highest and best use, or maybe even going back to the Jim Collins and Good to Great days or the lean manufacturing days. What is it that your customer pays you to do? That's your raison d'etre, your reason for existence. Let's focus on that and let other experts worry and figure out how to solve those problems. You're right. I mean, first of all, the United States is full of small to mid-sized companies. We had Ashutosh Pati, who's the managing director. At the time, he's a managing director in North America for McKinsey and Company, wrote a book called The Titanium Economy. He's since been promoted to be their international head of strategy for all of McKinsey, 45,000 consulting employees around the globe, one of the top 3 consulting companies by many measures on the planet. And he was on the podcast talking about how literally 70% of all research and development and innovation happen in the American economy happens in small to mid-sized manufacturing. So you think about all of the R&D, all of the innovation that happens all across the United States of America, 70% of that happens in small to mid-sized manufacturing. And so that is by and large where a lot of our innovation takes place here in the United States. And of course, in the same way that things like the space program drive innovation across all kinds of spaces, the innovation that happens in manufacturing pervades manufacturing into every space within our economy. Additive manufacturing, you're right, for a while it wasn't worth the hype. I was somebody that for a long time, I think as you know, was wondering what we were doing in education, just putting all of these farms of 3D printers into education and watching students download STL files to a 3D printer and print out a Yoda head, for example. And it's like, well, that's kind of cool, but I'm not sure beyond like one of those injection molding things you do at the zoo, what the students are necessarily learning there. And now here we have this opportunity into things like different technologies, different materials. We've got way more applications for additive. The prices are coming down. The complexity of the parts is going up. The usefulness of the parts is going up. Really, really cool time to be in your space. And B9 Creations couldn't be in a better spot, I think, than you are right now. I think one of the spots that a lot of our employers are trying to figure out, to your earlier point, is around talent, right? It's not practical probably for your average $20 million manufacturing company to hire $250,000 a year additive manufacturing engineer. I'm making those numbers up, but I'm probably not too far off. So if I'm a company that is looking at the workforce side of it, what do we have to do here in the United States and beyond from a workforce standpoint, just thinking about what those challenges are and then how additive can help manage through some of those challenges?
Well, I'll respond to your question with 2 parts. One being where I think there's some opportunities to improve, but then number 2, where I think we're seeing some real encouraging signs.
Awesome.
So part 1 of that would be, you touched on it. When 3D printing was first adopted in the education space, it's, well, you know what, we need is 100 of these, so we need to buy them cheap.
Right.
And then within 6 months of the 100 you bought, 10 still work. But the teacher who used to run that program has now moved to a different program. And, now nobody's left that knows how to operate these things. I think the fascination with the mechanical process of making the part is good. And, the mechanical engineer in me gets a little kick out of that. But additive manufacturing, unless you're the person who's under the hood working in the firmware of the machine, it's a software process. So what we have to do on the education side is think about, yes, ultimately, I think there's a lot of value in the students being able to produce a part, but understanding the design considerations and layout and support and all of these things that really can be experienced through software, which is infinitely more scalable than hardware. And usually you do a lot less maintenance on software than hardware.
Right.
Make maybe the same investment in a smaller volume of hardware platforms, but invest in hardware that A, is robust, and that B, might even look like something the students are going to see in industry.
Right.
Instead of, I've printed a ton of stuff on a $300 filament printer or $1,000 filament printer, the parts are junk and the surface finish is terrible and all that, but to your point, it's cool, I got a Yoda head. If I had a student, when we interview, whether it's engineering or technician level, if someone comes to B9 and applies for a job and says, hey, I understand orientation in 3 dimensions and layout and support and design considerations around overhangs and things like that, give me that all day long over somebody that says, oh yeah, I bought a XYZ brand 3D printer and I leveled the build table all by myself and I controlled the temperature, because a good piece of hardware is going to do all that for you anyway. So part two of that, part one, the part that was a little discouraging is we saw a lot of people throw a ton of money at fairly low quality hardware that came with almost no support. And so if you go anywhere in education, there are a lot of those 3D printer manufacturers need a partnership with Swiffer because they mainly collect dust after they've been there 6 months.
Right.
The encouraging part, though, is we are really seeing some creative things. There are some innovative people when we think about people like Uplift Education and some other folks in the space who are moving well beyond that, if we want to call it additive in education 1.0, well beyond that in terms of how they think about engaging students and realizing, it's not just the student that knows I want to be an engineer. It's the people that in the past would have done graphic design, that was a very two-dimensional thing, that now are thinking, how do we teach them to think in 3 dimensions? There's an artistic component, a design component, a frankly sales and marketing, customer feedback component. I know Tech Ed Podcast is all about STEM, but so often I find that people have this very limited view of STEM. And so, well, my kid doesn't want to be an engineer, so I guess that doesn't really apply.
Right.
And I try to be quick to show examples of that, but we're seeing these really innovative partnerships between a company like a B9, a customer of a B9, and some names that I can use, a company like a Medtronic,
Sure.
where they are partnering with community colleges and other educational institutions. So the education institution is very difficult to figure out what does industry really value if they're not talking. And
Right.
what I see that's so encouraging to me is more and more of our customer base on the industrial side talking to more and more of our customer base on the educational side. And frequently we get to be a part of the cool thing that happens there.
That for sure you do. And I've been a part of a number of those as well. It's been interesting to see the last 10 years how much more involved so many of our large and even small and mid-sized manufacturing companies and other companies involved in the STEM space have engaged with education, be it a technical or community college, a engineering university, or probably my favorite, those K-12 programs, because there's so much opportunity there. I can think back, Shon, to several years ago, 10 plus years ago, when additive was coming of age in education and walking into one of our local educational institutions before I was on the education side myself. And they wanted to show me their manufacturing program. And we walked in to see the manufacturing program. And of course, they had to your point, 10 early stage filament 3D printers and maybe one computer. But I remember the superintendent of that school district walking me in and saying, well, this is our advanced manufacturing program. And I said, well, where? And they said, well, these 3D printers. And to that point, I had only seen 2 3D printers in manufacturing. One was at the same motorcycle manufacturing company that I alluded to earlier. And that was 3 levels behind the front desk security. Like if you could get all the way into their deep R&D program, if you had access there, you saw one. I also saw one at a major marine manufacturing company here in the Midwest as well. Those were the only 2 I had ever seen. And the superintendent said, these are exactly the same 3D printers that manufacturers are using in their processes. And I said, oh, really? Who told you that? So they said, well, the person that sold us the 3D printer. I'm like, well, yeah, of course they did. Now we've seen in the last 10 years, obviously, with the advancements in the technology, so many applications in education. I'm a huge, huge fan for additive in education when it's done right and when you're teaching the right competencies, as you suggested. When you talk to, and I know you spend a lot of time around elementary schools and you spend a lot of time around K-12 and middle schools and so on, you talk to students, you have them come tour your facilities. Are they starting to understand the kind of careers that are available in the world of additive, either as a standalone career or how it might affect where their career is going, regardless of the discipline that they choose to pursue? And what are some of those things that we can do even better in terms of helping students understand what all the opportunities are?
There's a lot of work to be done, in my opinion, there, Matt. I mean, the needle's moving, but it's moving slowly. In some ways, we're having a little fun at the expense of engineers, and
right.
That's okay.
I'm married to one, by the way, so I can get away with that, right?
You and my wife could get together and sympathize with each other.
Have a support group. Count me in.
The good news is your wife, Renee, and I never miss the opportunity to overanalyze something, probably. But when we think about education, so often people tend to be focused in their swim lane. So if I'm a science educator, or if I am in the K through 12 environment, or I am a math teacher, or if we get to that community college environment and I am a electronics program or advanced manufacturing program, there's a lot of in the swim lane thinking. And I think what's missing for kids, particularly in K through 12, I mean, if you asked most K through 12 students and you said, what do you want to be when you grow up? I mean, I had 2 kids, but it went from so I had a boy and a girl. So it started out like astronaut, ballerina, and then you get to the professional athlete stage. And then you get beyond that and it's like, I don't know.
Right. Deer in the headlights. Yeah.
This is more complicated than I thought. I think where we miss the boat is we've got a ton of thinking and I get it. We need tests and we need to assess these students' capabilities, but I don't know that we're spending enough time helping them figure out what they ought to do when they grow up.
Right.
So the good news is I think and I'm mainly going to speak about the U.S. because I'm a lot less knowledgeable outside the U.S., but I think as a country, we're waking up to the fact that, you know what, college is a really expensive place to figure out what you want to do if you grow up.
For sure.
We should do more of that earlier. Not that you have to pick one thing and do it forever. I still don't think that's the career path. That hasn't been the career path even of the last 10 years.
None of us did, right?
Right.
I'm on career number 5 or 6, I think, at this point.
Yeah, I don't think it's the career path of the future, but I think it's how do we help our young people understand how to make some choices that move you forward and keep options open. I'll pick on myself. Growing up, I was that kid. He always played with Legos, good at math, and everybody's like, you should be an engineer. And I really thought when I was in junior high, I wanted to be a mechanical engineer and I wanted to work on the aerodynamics for new Corvettes. That's every car nut kid's dream.
Right.
And I went to engineering school. I took this class called fluid mechanics. It and I did not get along well together. And you realize, I had a couple of internships while I was in engineering school. And you realize the guys that are doing the things that I wanted to do, A, they're not wired like I am. And B, they're a lot better at some of those detailed, deep dive computational analytics types things than I was. And so, I was a kid that I would have said, I know what I want to do from the time I was in about the 6th grade. But when I got to the point I actually got exposed to it, I realized this actually isn't what I should do.
Right.
What I try to focus on now is how do we help people figure out what they should do based on their own gifts and talents, and then use those gifts and talents to create value for themselves and the world around them. And it sounds a little bit esoteric, but one of the smartest guys I ever worked for used to use an example that for some of your listeners, I apologize that I'm going to use this analogy because if you live in Texas, it's painful. But when I first went to work for this guy, it was back in the 90s, and the Dallas Cowboys were the dominant team in the NFL. And he used to say, Shon, if you had the same team, so same talent, but Troy Aikman played wide receiver, Emmitt Smith played quarterback, and Michael Irvin played running back, how many games would they win?
Right. Yeah.
And the answer
That's
is
great.
maybe a few, but a whole lot less. And again, I apologize to the Cowboys fans who are still living through the Super Bowl drought. But the same is true of our young people. Helping them figure out, am I a quarterback, running back, wide receiver? We'll pick the analogy that works. But today, I don't think we spend enough time and energy on helping them understand that about themselves. And it's easy to get excited about, additive in the classroom and all that. But I think we have to step back and take that, again, not just in the swim lane view, but we got to view these students as people,
right?
They need exposure to different things and experiences and the opportunity to make choices that still leave options open in front of them, and realize, I've had to tell my own kids this, sometimes the most valuable lesson you can learn is what you don't want to do. And you take a job that sounded cool and you're like, you know what? Actually, this is not my thing.
It's interesting as we record this, I just had lunch this afternoon with I won't name the university, but with the provost, the chief academic officer of an engineering university. And we were talking about the importance of starting to morph the engineering education process into more hands-on experiential learning early on. So we don't necessarily get to our junior year of an engineering program that might be costing, a student or their parents or some combination thereof, or somebody else for that matter, $40, $50, $60, $80,000 a year, to find out that this really isn't what I wanted to do, or maybe, calculus and physics aren't my thing. And so we get some of that hands-on experiential learning early on so they can really get a sense for what it's like to work as an engineer, and maybe decide even sooner if that's not the right path, to your point, because that's as important as figuring out what is, and get on the right one, and then driving that back into high school and middle school. We talk all the time on the podcast about how the number one influencer of a young person's career pathway is their own interests and experiences in middle school and high school, and nothing else is even close. It's not parents, it's not social media, it's not academic advisors, it's not their friends. It's what they'd like to do. It's what they're interested in. I'm a firm believer that if we can figure out, everybody has their own special powers. They're different for everybody. But if you can figure out what yours are, mine were always kind of like economics and then this communication thing. I could always find my way through a sentence. If you can find a way to make a living doing what you love to do, then work becomes a lot more fun. It becomes more of a vocation. But we need to have young people figure that out earlier. Not that they have to choose a career when they're 12 or 13 years old, but understand what you love to do, understand what interests you, and then try and find a career somewhere along the way that you absolutely love to do. Talking about one of the things that you mentioned, Shon, what was it? Aerodynamics on Corvettes? Was that the example that you used?
Yeah, that was my dream until I crashed into the reality of fluid mechanics class.
Right. Yeah, exactly. I just want to tell this story. When I was growing up, that was the thing, right? Kids, you worked on your cars, and whether you're just doing things like tinting windows, or you had the entire engine block torn apart in your garage or somewhere in between. That was kind of the thing to do. I was in Tokyo, this goes back about 5 years, and I was with two engineers, both of whom were working on a major project around Fanuc Robotics. So let's just kind of keep it that way, because they were customers of Fanuc that I was with. And they were talking about integrating manufacturing technology in the same way that people of our generation talked about, like souping up their car in some really cool way. And they're like, oh man, you mean you integrated that Bosch sensor with a Siemens PLC and a Schneider electric switch? And, they're just like having this conversation. And, you had this Rockwell VFD that was doing such and such, talking about integrating manufacturing technology the same way that we used to talk about putting together really, really cool things on our cars. And so I tell people, of our generation, maybe a little bit younger, if you think about the way that we used to talk about what we did with cars, that's the same way that students and young people can talk about integrating manufacturing technology. Certainly additive is a huge, huge part of that. And so bringing additive to education in the right way, Shon, I think really, really important, and delivering it in the right way. And we've already talked about the fact that it's not just 20 filament printers, all printing the same thing that some student downloaded from the internet, but it is the software side, it's the integration side, it's materials, it's design for additive, all these other things. When you're talking to educators, whether that's a high school teacher, a CTE director, maybe a dean at a college or a university, where is education falling short when it comes to teaching additive?
That's a complex answer because it's a little different for every organization. But what I would love to see based on the folks I've talked to is more focus on where it can take you than on additive itself. And maybe that's heresy for a CEO of a 3D printing company to say. But I think if you want to engage these kids, yes, there are going to be some that are going to say, oh my gosh, I can I 3D printed a holder for my iPhone so I can clip it onto my mountain bike or whatever. But there are a whole lot of kids that they're smart enough to know, hey, the world I am headed into, additive manufacturing is going to be a disruptive force, but where can it take me? Because maybe I'm not the kid that wants to design the part. Maybe I'm not the kid that wants to write the code. How can I do something with this or do something around this? And for instance, I'll call out something that we've been talking about this learning curve of how we have generations of engineers who know how to design for molding. Mm-hmm. Now we got to teach a generation of engineers how to design for additive. What if your passion was teaching and training? And I don't mean that you have to go become a PhD in a university and teach that dang fluid mechanics class that scared me out of aerodynamics. But what if your passion is teaching and training maybe in a corporate environment where it's much more about the application of the technology than how to write the code that moves the parts of the printer up and down? There's opportunities all the way around this, Matt, but we've got to go from the fascination with the technology itself back to where can it take you? I'll say something a little controversial.
We love controversial. Go ahead.
A bunch of people will probably mishear what I'm about to say, but if you think about your kid's school, if you have kids in school, or back when I was in school, the dinosaurs had just died off. You look at the amount of organizational bandwidth and money and energy that we put into something like athletics. And don't mishear me. I'm not against athletics. I ran track, ran cross country, all that good stuff. And there are a lot of good lessons that the handful of kids who are in that can learn from it. But how are we helping these kids understand how additive manufacturing, AI, some of these other macro forces can create opportunity for them? Because I've met with those CTE directors that have been sent there with, these poor men and women, it's like, hey, at least David had a slingshot.
Right.
Some of these people, you got the basketball coach, he's hauling people around on the bus, he's got a huge budget, and the poor CTE director is the one-man band who's supposed to mobilize a bunch of people who kind of are motivated to just do their job and not let him distract them.
Right.
And then we wonder why some of this isn't getting traction. So I think we have to take a step back to your, it's like the hedgehog concept from good to great, right?
Right.
What is it we can be the best in the world at in education? And if our goal is create, I would call them young adults, which might not be the right word, but young adults who understand the world they're coming into and how to find their way in it. If that's the goal, we need a lot more resource around how do we help them with self-awareness? How do we help identify gifts and talents? And then how do we show them how to connect those gifts and talents into the career fields that are emerging in the world ahead of us? So that was a wide-ranging answer around, education around additive, but let's get beyond the programming the mechanical movements, and let's get beyond the engineering the part, and let's talk to the broader swath of kids. Because again, if our goal is to make the majority of kids into software engineers, that's a long putt. We're never going to get there. Mm-hmm. Now, if we say our goal is excite kids about technology and help them figure out based on their gifts and talents, what should they do around that? That's a game I think we can win.
That's a game we can win for sure. And in as much as we put, you're right, all kinds of money into referendums, for example, to build new sports stadiums and new gyms and so on. And again, I'm the same way. I'm a product of high school athletics. So are my kids. Certainly wouldn't say anything bad about that. And if we made the same kind of investments in STEM and learning centers as we do in athletic facilities and so on, not taking anything away from the latter, think about how much further ahead we might be. I think that's a really, really good way of looking at it. And then thinking about how we educate the whole student around all of the opportunities that might be standing in front of them. We've got time for one more question with Shon Anderson, the CEO of B9 Creations. And Shon, that question's a question that's going to lead right off of the last discussion around how we inspire young people into the right career pathways and give them the right competencies and skills to get on the right track. And that is taking you all the way back to your high school days. Let's say, for instance, that you are a 15-year-old sophomore in high school. If you could give that young man one piece of advice, what would you tell him?
Well, this may sound a little bit cliche, but for me, it would have been, don't worry about failure. I think oftentimes, and I'm stereotyping a little bit, but the people that lean more toward engineering tend to be more motivated around finding the right answer.
Mm-hmm.
And then you realize when you get out of school that most questions in life don't have one right answer.
Right.
And so I would have told myself, take more risks faster.
Take more risks faster. I love it. We have a saying around here that says perfection is the enemy of progress. We have another one, by the way, that says there comes a time in every project where you shoot the engineers and release the product. That's another one that I'm sure you can relate to really, really well. I've enjoyed relating to all the things, Shon, that we talked about here on the Tech Ed podcast. You're doing amazing things at B9 Creations. I know our listeners are going to be interested in learning more. We'll drop some things in the show notes about your company and all the great things you're doing. But can't thank you enough for being with me on the Tech Ed podcast.
Thank you, Matt. It's been a blast, and just want to encourage you, keep fighting the good fight around STEM education and enabling that next generation of workforce.
We had so much fun fighting the good fight with Shon Anderson here on this episode of the Tech Ed podcast. I hope you enjoyed it as much as I did. We certainly, and I knew this is how it was going to go, we would talk a little bit about additive manufacturing and 3D printing and the careers and the opportunities available, but we also got deep into what we need to be doing in education, how we need to be thinking differently about different technologies in manufacturing. Covered so much ground with Shon, and I had a wonderful time. I know you enjoyed this episode as well. We have all kinds of things to link up in the show notes, so check them out. We have the best show notes in the business. By the way, those show notes will be at techedpodcast.com/Shon. That's techedpodcast.com/SHON. My name is Matt Kirchner. Thank you so much for being with us. We'll see you next week on the Tech Ed Podcast.